So today we have another concept of acid and bases, that is known as Bronsted-Lowry concept of acid and bases. अब ये जो concept है ना, Arrhenius has its limitations. It applies to aqueous solution. So the major limitation or drawback of Arrhenius theory is that it is applicable only on aqueous solution, means solutions in water. कल हम लोगों ने क्या पढ़ा था? If we have HCl and if you dissolve this HCl within the water, if it produce proton ion and chloride ion, due to the production of this proton ion, we can categorize HCl as an acid. Same for sulfuric acid, phosphoric acid, and so on. For all these acids, there must be the presence of water molecule. So this is the major limitation of Arrhenius theory. It does not explain why compound like carbon dioxide, sulfur dioxide, etc. are acidic. If we talk about carbon dioxide, if we talk about sulfur dioxide, then we say that these both are acids. Carbon dioxide is an acid and sulfur dioxide is an acid, although they do not have any proton. As per the concept of Arrhenius theory, acid is that species or substance which has the ability to donate proton. But in case of sulfur dioxide and carbon dioxide, we don't have any hydrogen atom, but still their nature is acidic in nature. So this was not explained by Arrhenius theory. Same is the case with ammonia molecule. Ammonia act as a base. Ammonia act as a base, but it don't produce hydroxide ion. And as per the concept of Arrhenius theory, bases are those substances which has the ability to donate hydroxide ion. ठीक है? So these were the limitation of Arrhenius theory. और उसके बाद हमारे पास एक और बंदा आया, बल्कि दो बंदे थे, ब्रॉन्स्टेड एंड लोरी. इन्होंने कॉन्सेप्ट दिया अबाउट एसिड एंड बेसिस. In 1923, by the way, do you know why carbon dioxide and sulfur dioxide are acidic in nature? When carbon dioxide react with water, it will form H2CO3, which is known as carbonic acid. And same is the case of sulfur dioxide. When it dissolves in water, it will produce H2SO3, which is known as sulfurous acid. Sulfuric acid में H2SO4 होता है. H2SO3 means sulfurous acid. Anyways, that is the basic reason that why carbon dioxide and sulfur dioxide are acidic, but Arrhenius was unable to explain this concept. Same is the case with ammonia. Ammonia act as a base. Why it act as a base? Because of the presence of this lone pair of electron, it can accept a proton, that we will discuss in this concept. In 1923, G. and Bronsted and T. M. Lowry independently proposed another theory to overcome the shortcoming of Arrhenius theory. So देखें, साइंस इज ऑल अबाउट थ्योरीज. एक बंदा अपना कॉन्सेप्ट देता है, अगला आके उसको कहता है नहीं इसका गलत है, मैं अपना दे देता हूँ, एंड सो ऑन. सो सबसे पहले कॉन्सेप्ट अरहीनियस ने दिया, देन वी वर हैविंग अनदर टू केमिस्ट, ब्रॉन्स्टेड एंड लोरी. They give another concept about acid and bases. This theory was known as Bronsted-Lowry theory or concept. According to this theory, in acid is a proton donor. Acid is a proton donor. Base is a proton acceptor. अब ये आपने याद करना होगा कि acid is a proton donor while base is a proton acceptor. Here we have an example. जब हम example पढ़ लेंगे, so we will know these concepts. In this case, we have an HCl molecule which act as an acid, and similarly we have water molecule which act as a base. Now in this case, what happened? We have this water molecule having two lone pair of electron. Water molecule is having two lone pair of electrons. Lewis dot and cross structure. He has 6 electrons. So 1, 2, 3, 4, 5 और 6. ये हो जाएंगे 6 इलेक्ट्रॉन्स. ठीक है, ये जो आपके पास है, these belongs to the hydrogen atom. Now In this case, as you can see that you have two lone pair of electrons, 1 and 2. And electron, what is the charge on an electron? That is negative charge. If you have an HCl molecule, if you have HCl molecule, in case of chlorine, we have 7 valence electron. I hope you already know about this, that why it has 7 electrons.
Yes, sir.
Okay. In case of hydrogen, we have only 1 electron, so we can represent its electron with cross. Same is the case with this one. आप यहाँ पे इसको cross से represent कर दो. Now, there is a difference of electronegativity between chlorine and hydrogen atom. So, chlorine is more electronegative. Chlorine is more electronegative as compared to hydrogen atom. So what will happen? This chlorine will drag the electron of hydrogen toward itself. Chlorine will drag the electron of hydrogen toward itself. Resultantly, chlorine will carry partial negative charge while hydrogen will carry partial positive charge. Hence, we can say that this HCl hydrochloric acid molecule is polar in nature. ये हमारे पास क्या है? This is polar in nature because it have partial positive and partial negative pole. Now, since oxygen atom has a lone pair of electrons, it is having negative charge, electrons carries negative charge. Here we have positive charge on hydrogen atom, which is electron deficient. This is electron deficient. इसका अपना इलेक्ट्रॉन किसने खींच लिया?
Chlorine.
Chlorine. Hence, this is acting as an electron deficient hydrogen atom. So this negative charge is going to attack on this positively charged hydrogen atom. This negative charge having lone pair of electron will attack on this partial positively charged hydrogen atom, and if it will attack, there would be the formation of dative bond, जो कल हम लोगों ने पढ़ा था ना, कोऑर्डिनेट कोवेलेंट बॉन्ड. यहाँ पे जब ये अटैक करेगा तो यहाँ पे कौन सा बॉन्ड बनेगा? कोऑर्डिनेट कोवेलेंट बॉन्ड. और ये जो इलेक्ट्रॉन है यहाँ से एक पूरा पेयर डोनेट कर रहा है, तो इसके सो पेयर मिल जाएगा. सो ये जो इलेक्ट्रॉन है हाइड्रोजन का, इट विल बी शिफ्टेड टुवर्ड द chlorine site. And what you will get? You will get the formation of this type of ion. Hydrogen will be attached. You will be having one lone pair left. ये हमारे पास 2 lone pair थे ना, एक तो यहाँ पे यूज हो गया, एक हमारे पास रह जाएगा. ऑक्सीजन ने 3 बॉन्ड बना लें तो इसके ऊपर चार्ज होगा, दैट वुड बी पॉजिटिव. Similarly, chlorine was having 7 electron in its valence shell, but 1 electron of the hydrogen is shifted toward the chlorine, so it will be having negative charge. So we will have 2 types of ions, cation and anion. Now in this case, which one is the proton donor? H positive. If you have water molecule, if it attack on this hydrogen, this proton, what will happen? We will get this type of ion, which is known as hydronium ion. This is known as hydronium ion, and this is the same. ये भी hydronium ion है. You will be left with chloride ion. So ये हमारे पास chloride ion है. So proton donor in this case is HCl. देखें यहाँ पे H और Cl कंबाइन है कि नहीं है रिएक्टेंट साइड पे. यहाँ पे प्रोडक्ट साइड पे आपको क्लोराइड आयन नजर आ रहा है ना, इसका हाइड्रोजन किधर गया?
Oh, it's gone with the oxygen. It's
ऑक्सीजन ऑफ वाटर मॉलिक्यूल, ऐसा ही है.
yes, sir.
So अगर आपसे कोई पूछता है कि प्रोटॉन डोनर कौन है तो क्या कहोगे आप? The HCl molecule on the reactant side. Let's repeat it. We have HCl molecule, we have a water molecule. It is having lone pair of electron. Because of the electronegativity difference, ये तो समझ आ गई होगी ना, ये हमारे पास क्या है?
Yes, sir.
पार्शियल नेगेटिव पार्शियल पॉजिटिव चार्जेस हैं. This oxygen atom is having these two lone pair of electrons. What is the charge on electrons?
Electrons have negative charge.
Negative charge. And what is the charge on this hydrogen atom?
Positive.
Partial positive. And what happens when there are positive and negative charges?
They would attract each other.
There would be forces of attractions. So if this water molecule is having lone pair of electron and it is having negative charge, so on what part of this molecule these lone pair are going to attack?
The hydrogen
With hydrogen. So this negative charge will attack on hydrogen atom, and resultantly what happen? This electron of hydrogen will be shifted toward
towards chlorine.
chlorine, and you will get the formation of chloride ion, right? Already it is having 7 valence electron. एक इलेक्ट्रॉन हाइड्रोजन का भी इसके पास आ जाएगा तो इसके ऊपर कितना इलेक्ट्रॉन्स कितने हो जाएंगे?
8 valence electrons.
8 वैलेंस इलेक्ट्रॉनों के, तो इसके ऊपर चार्ज कौन सा आएगा? नेगेटिव,
Negative.
क्योंकि इसने इलेक्ट्रॉन क्या किया? गेन किया है। कहाँ से? हाइड्रोजन से उसका इलेक्ट्रॉन ले लिया होगा। ऑन द अदर साइड, this is the water molecule and it has used this lone pair of electron to abstract proton from an acid, and this lone pair will remain intact. It will not react or it will not take part in bonding. So we will get the formation of this ion which is known as hydronium ion. ठीक है? This is known as hydronium ion and this one is known as chloride ion. Now I think you might have got some idea about this type of bonding. Actually these are known as mechanism of action. These are known as mechanism, that how chemical reactions proceed. आपको तो सिंपल कराया जाता है ना कि कार्बन डाइऑक्साइड सल्फर डाइऑक्साइड के साथ रिएक्ट कर गया, लेकिन कैसे रिएक्ट किया गया तो एक्चुअली इस तरह होता है। अब यहाँ पे देखो H और Cl कंबाइन है कि नहीं है रिएक्टेंट साइड पे?
Yes, sir.
प्रोडक्ट साइड पे Cl के साथ हाइड्रोजन है?
No, sir.
तो किधर गया?
So it's attached with the water molecule.
It's attached with the water molecule. Now in this case, this is a water molecule. How many hydrogen atom are there?
3, sir.
3. On the product side, how many hydrogens are attached with oxygen atom?
So there are 3.
There are 3 hydrogen atom. So can you please tell that from which side or from which part of the molecule this hydrogen has come?
So it came from HCl.
From HCl. So can we say that HCl is a proton donor?
Yes, sir.
So if HCl is a proton donor, it would act as an acid. यही हमारे पास कॉन्सेप्ट है अबाउट लोरी एंड ब्रॉन्स्टेड कि एसिड जो है वो क्या होता है, दैट इज प्रोटॉन डोनर while base is known as proton acceptor. अब इसमें प्रोटॉन किसने एक्सेप्ट किया है?
The water molecule.
Water molecule. So water would act as a base.
Base.
So now there are various questions. Okay, remove this arrow from this side because whenever we study about chemistry, so negative charges attract on the positively charged atom. So this is wrong. This would be partial negative charge. Hydrogen is having partial positive charge. Lone pair will attack on this partial positively charged hydrogen atom. Since HCl is a proton donor, so it would act as an acid. Proton is accepted by this water molecule, so water would act as a base. You will get the formation of 2 types of ion. One is known as hydronium ion and the second one is known as chloride ion. So question number 1, which substance is donating proton?
So HCl.
HCl, very good. Hydrochloric acid. HCl is hydrochloric acid. Yeah, it is also known as hydrogen chloride. Similarly, question number 2, which substance is accepting proton?
The H2O water molecule.
H2O, which is a water molecule. Which substance is acid?
HCl.
HCl, because it is donating proton. Which substance is base?
H2O.
H2O. So I think we are all done with this example. Then, where does the hydroxide come from the ionization of bases such as ammonia? The Arrhenius theory is inadequate to answer this question. Since ammonia molecule, in case of ammonia molecule, we have 3 hydrogen atoms. Would it be possible for it to form hydroxide ion?
No, sir.
No. So these were the limitation of Arrhenius theory. But the Bronsted-Lowry theory explain how ammonia act as a base in water. Now for this, we need to have a blank space. Now we have ammonia molecule, nitrogen atom. It is attached with 3 hydrogen atoms. And we have a water molecule. आवाज आ रही है आपको मेरी?
Yes, sir.
Okay. So this is the structure for ammonia, NH3, and this one is the water molecule. So you are familiar with both of them. Now in this case, what happened? As you can see, that water molecule is polar in nature. Water molecule is polar in nature because of the difference of electronegativity between oxygen and hydrogen atom. Oxygen is having more electronegativity, so it will drag the electron of hydrogen toward itself. Same is the case with this hydrogen atom, and resultantly we will be having partial negatively charged oxygen atom and partial positively charged hydrogen atom and partial positively charged hydrogen atom. So whenever we react these molecules, what will happen? This nitrogen atom of ammonia is having lone pair of electron, and as you know that lone pair carries negative charge. Lone pairs are actually electrons, so it is having negative charge. So this lone pair is going to attack on this proton, and resultantly what will happen? This electron of hydrogen will be shifted toward oxygen atom, and we will get NH4 along with OH negative ion. This is known as ammonium ion, and this one is known as hydroxide ion. Now in this case, what happens that ammonia is having lone pair of electrons, so it will make a coordinate covalent bond. This is known as coordinate covalent bond with hydrogen atom. Now in this case, which atom has donated its proton?
Sir, H2O.
H2O. So the species that can donate proton would act as an
Acid.
acid. So water as acid. And which species has accepted proton?
NH3.
NH3. So that is why ammonia would act as a base. This is the concept of Lowry and Bronsted. So now as you can see, first of all, you have to change this arrow from nitrogen toward hydrogen. So partial negative charge, partial positive charge hydrogen, partial positive charge hydrogen. So lone pair of nitrogen would attack on this hydrogen atom, and this electron of hydrogen will be shifted toward this oxygen atom. So you will get the hydroxide ion and ammonium ion. This is ammonium ion. Which substance is donating proton? Ammonia or water?
H2O.
H2O. So which substance is proton acceptor?
NH3.
NH3. All the acid included in the Arrhenius theory are also acid in Bronsted-Lowry theory. However, all the bases included in Bronsted-Lowry theory except hydroxide are not Arrhenius bases. अच्छा, यहाँ पे एक चीज आपने नोट की है. In the first example, which we have studied about HCl and water, in this case we got the formation of what? Hydronium ion along with chloride ion. And this second example, we have the ammonia and it react with the water to form ammonium ion and hydroxide ion. So in this case, water was acting as a base, while in this case, water is acting as an acid. So it means, what is the nature of water molecule? Water is amphoteric in nature. Water is amphoteric in nature because it can act as an acid as well as base. आपने यहाँ पे दो एग्जांपल्स में देख लिया. एक जगह पे क्या एक्ट कर रहा है? बेस. दूसरी जगह पे क्या एक्ट कर रहा है?
Acid.
Acid. So all those species which has the ability to act as an acid as well as base are known as amphoteric substances. ठीक है. यहाँ पे लिखा हुआ है कि all the acid included in Arrhenius theory are also acid in Bronsted theory. Arrhenius concept के मुताबिक जो acids थे exactly वही चीज यहाँ पे acid है. लेकिन in case of bases क्या होता है? However, all the bases included in Bronsted-Lowry theory except hydroxide ion are not Arrhenius bases. Consider about two example. In one example, water molecule accept a proton and another water donates a proton. This means water behaves as an acid as well as base. It is amphoteric in nature. So underline this in your book that water is amphoteric substances. और ये बहुत important MCQ बन सकता है आपके पेपर में. Substances that react with both acid and bases are called amphoteric substances. So all those substances which has the ability to react with acid as well as bases are known as amphoteric substances. In this case, in the first case, water is reacting with HCl, which is an acid. In the second case, water is reacting with ammonia, which is a base. Hence, water is amphoteric in nature. And all those substances which can react with acid as well as base are known as amphoteric substances. Then we have society, technology, and science. Fossil fuels contain small amount of sulfur and nitrogen. They produce sulfur dioxide and oxide of nitrogen when the fuel is burned. Large amount of these oxides are released from coal burning factories and power stations. They react chemically with water vapors in clouds and oxygen in air, forming acids. What are fossil fuels?
So dead animals, the remains of dead animals and plants.
Yes, dead remains of animal or plants which were once living. Okay, fossil fuels contain small amount of sulfur as well as nitrogen, and sulfur has its own oxides and nitrogen has its own oxide. Oxide means whenever they react with oxygen atom, like sulfur dioxide, sulfur trioxide, nitrogen dioxide, nitrogen monoxide. These all are known as oxides of sulfur and nitrogen respectively. So whenever you burn the fuel, then you get the formation of sulfur dioxide and formation of nitrogen oxide. Large amount of these oxide are released from coal. Coal burning factories and power station produce large amount of oxides of sulfur and nitrogen. Now these oxides, they are having gaseous state, so they will move into the open atmosphere where they react with clouds and oxygen in air and they form acid. Like we have sulfur dioxide, we have nitrogen dioxide. These oxide come from coal burning factories and power station, and in the atmosphere they react with oxygen as well as water molecule and they form acid. This is sulfuric acid and this one is the nitric acid. And when this water come into our atmosphere, we say that this is the acid rain. These acid mix up with raindrops and fall as acid rain or acid snow. Now we have example 10.1 classify substances as acid. अच्छा, इसमें कोई मसला तो नहीं है सोसाइटी टेक्नोलॉजी के अंदर?
No, so it's clear.
Okay. Classify substances, acid or bases, are proton donor or proton acceptor. Identify Bronsted-Lowry. I said these questions are very important. From paper point of view, these questions are important. Now in the first example, we have HCl, we have water, we have hydronium ion, we have chloride ion. HCl react with water to produce hydronium ion and chloride ion. Now which one is acid in this example?
So HCl,
HCl is an acid. And which one is base?
H2O water.
Which one is proton donor?
So HCl,
And which is proton acceptor?
H2O,
H2O. Now in case of water and ammonia, which one is proton donor?
H2O,
H2O. So it would act as a base. And which one is it would act as an acid? Which one would act as a base?
NH3.
NH3. NH3 is ammonia. Acid is a proton donor. After donating proton in acid form negative ion. हाँ ये important है. Like हमने पढ़ा ना HCl plus water. It will form hydronium ion and chloride ion. So whenever acid donated its proton, it will be converted into negative ion, which is known as anion. Negative ion को आप क्या कहते हो? anion. And base में क्या होगा? Base after accepting a proton, it would be converted into positive ion. तो यहाँ पे लिखा हुआ है. Then you have self-assessment exercise 10.1. In this case, sulfuric acid react with water to produce bisulfate ion and hydronium ion. Acetic acid with water. Sulfuric acid का structure कैसे होता है? Sulfur belongs to group 6A, hence it can make 6 bond. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5 and 6. 6 valence electron. Oxygen, same is the case with oxygen. It is having 6 valence electron. It can make 2 bonds. And in this case, it is having 2 lone pair of electron. In this case, it also have 2 lone pair of electron. In this case, oxygen has 2 lone pair of electrons. Now in this case, what happened? That this oxygen atom being more electronegative as compared to hydrogen atom, it will drag the electron of hydrogen to it itself. Resultantly, hydrogen will have partial positive charge and oxygen atom will have partial negative charge. If you react this with water molecule, water is having lone pair of electron. These lone pair of electron will attack on this partial positively charged hydrogen atom, and this electron of hydrogen will be shifted toward oxygen atom, and resultantly we will get what? First of all, we will get the formation of hydronium ion. This is known as, so first of all we will get the hydronium ion, and then after removal of this proton, we will be left with hydrogen, oxygen, sulfur, and O negative ion, which can be collectively written as HSO4 negative ion. Now in this case, which one is proton donor?
So H2SO4,
Sulfuric acid. So proton donor is known as
acid.
And water is proton
Proton acceptor.
acceptor. So it would act as a base. So ये आपके पास यहाँ पे था. So I thought कि मैं आपको करा दूं कि ऐसा ना हो कि आप इसके अंदर कंफ्यूज हो जाए. So this is acid और ये हमारे पास क्या है? This is base. Then we have acetic acid, CH3COOOH. This is acetic acid. Whenever it react with water, now in this case oxygen is having partial negative charge, hydrogen is having partial positive charge, so it will drag the electron of hydrogen toward itself. Resultantly we will be having the formation of partial positively charged hydrogen atom, which is electron deficient, and partial negatively charged oxygen atom. Now in this case, water molecule is having lone pair of electron, so with the use of its lone pair, it will attack on this hydrogen atom. This electron of hydrogen will be shifted toward this oxygen atom, and we will get the formation of what? Hydronium ion. This is known as hydronium ion. And secondly, we will get CH3 C double bond O oxygen with a negative charge because it have gained or abstracted the electron of hydrogen atom. Now this is hydronium ion, and this one is known as what? इसको आप क्या कहते हो? ये जो आयन बन गया नेगेटिव, इसको इसका नाम क्या है?
Sir, oxygen.
नो दिस, ये जो हमारे पास पूरा आयन है, इस आयन का क्या नाम है?
Sir, CH3COO.
हाँ, नेम क्या है इसका? This is known as
Sir,
acetate ion. This is known as acetate ion. Acetic acid, after the removal of its proton, it would be converted into acetate ion. Now in this case, which one is a proton donor?
so CH3COOH.
Acetic acid. So this is proton donor, hence it is acid, and water proton acceptor, so it would be a base. ये आप आज खुद ट्राई करेंगी, फिर मैं आपको कल इसके बारे में बता दूंगा. हाइड्रोजन सल्फाइड, H2S is known as hydrogen sulfide. Hydrogen sulfide. And NH3, you know, ammonia, ammonium ion, and bisulfate ion. Bisulfide ion, sorry, not sulfate ion. So ये आपने आज खुद करना है, आपने बताना है कि कौन सा एसिड होगा और कौन सा बेस होगा. We have completed this whole concept of Lowry and Bronsted. So at the end, if I repeat, so acid जो होता है ना, that is proton donor, base is proton acceptor. और बेस प्रोटॉन एक्सेप्ट क्यों करता है? बिकॉज ऑफ द प्रेजेंस ऑफ लॉन पेयर ऑफ इलेक्ट्रॉन्स. अगर लॉन पेयर ऑफ इलेक्ट्रॉन्स नहीं होंगे तो फिर वो एक्सेप्ट नहीं कर पाएगा. और एसिड जो है ना, दैट शुड बी पोलर. एसिड जो है दैट शुड बी पोलर, देयर शुड बी इलेक्ट्रोनेगेटिविटी डिफरेंस, एंड देयर मस्ट बी द प्रेजेंस ऑफ प्रोटॉन. और उसके बाद हम लोगों ने पढ़ा वाटर के बारे में. वाटर कैन एक्ट एज एन एसिड as well as base. So all those substances which can act with which can act with acid as well as base, or which can react as an acid as well as base, are known as amphoteric substances. So this was all about Lowry in Bronsted concept. If you have any question from the whole topic, you may ask. So tomorrow, inshallah, we will learn about Levy's concept of acid and bases.